Hello and welcome to the Computer Vision Festival, hosted by the AI Accelerator Institute, a global community of over 400,000 AI leaders and practitioners, all striving towards one shared goal: inspiring the next generation of machine intelligence. With expert presentations on the festival agenda covering everything from space exploration on Mars to self-supervised learning, you're in for a treat. If you have any questions for our speakers or want to connect with them further, then ask away in the comments sections of the video and hear them answered at the end of each session in our live Q&As. If throughout the day you're loving the content, then be sure to check out the AI membership plans, where you can get access to exclusive content in the form of interviews, reports and articles. Access all areas passes to all past and future events. You can also join our Slack community, which is home to more than 2,500 fellow AI, machine learning and computer vision professionals, and is full of dynamic conversations and contributions. So if you're not already a member, come and join us today. Sign up using the link on the AI Accelerator Institute website. I want to say a massive thank you to all of our sponsors and partners for helping us to bring the festival to your screens today. Our amazing speakers for contributing some awesome content, and to you, our attendees, for joining us today. That's it from us, so go ahead, sit back, relax, and enjoy the festival.
Good morning, good afternoon, good evening, everyone. Thank you so much for the opportunity to present here at the Computer Vision Festival. I'm Parag, and I'm part of the IoT line of business at ARM. And today, I'm here to talk about the key trends that are transforming computer vision and security cameras. So with that, let's get started. Software-defined is really a trend these days. In today's world, there are many technologies that are software-defined. And this has been possible because of many advancements in technology. You can see here at the bottom of the stack, you have the operating system, then the virtualization layer, which actually kicked off the original software-defined compute with virtual machines, etc. Then came containers and orchestrators such as K3s, Kubernetes, etc. And these technological advancements paved the path to define a software-defined data center initially. And in the data center of software-defined compute, software-defined networking, and software-defined storage really started to become the norm. Now the time is prime to move this concept of software-defined to the embedded edge devices as well. This is really a transformation that has started across many segments such as automotive, cars, trucks, etc. I think if you own a Tesla, you should be receiving continuous software updates over time. And we do see this concept being applied to many other edge devices. And to be specific, one of them we expect is cameras, or what we call as smart cameras. The idea here is that once you receive or you buy a camera, the hardware is advanced so that you will actually be receiving continuous updates over time. And these are primarily software updates. And software updates can be neural network model updates catered to the specific data that you might have captured, or regular security updates, or many other updates related embracing or enhancing the functionalities of the device. So this is really the trend we are planning to see and drive the industry towards. At the same time, there's a huge transformation in progress for many computer vision and camera products. And this is primarily driven by three key trends. The first one being shift to edge compute. Until recently, cameras were just recording devices that were streaming content to digital video recorders or network video recorders, where the smartness was in these servers or gateways. However, we see a big change where compute is actually moving to the edge with AI-enabled intelligent cameras. Many aspects such as object detection, face recognition, etc., are increasingly available in the cameras themselves. This is the key transformation, what we call as shift to edge compute. The second trend that is increasingly getting focus is security. Right now, it's mandatory to ensure that all camera deployments are secure because of the nature of the data that they capture. And this is like no questions asked. The last trend that we see increasing adoption is cameras being cloud native. Being cloud native gives immense potential to cameras by running applications that can be deployed over time. If you buy a camera now, you can expect to see more and more upgrades to the cameras, thus extending the lifetime of the camera itself. Moreover, we also expect cloud native software development, wherein we expect many developers to develop the software in the cloud and then deploy them to the edge devices, which in this case would be the cameras. Now, let us go into a little bit detail in the first transformation aspect, which is the shift to edge compute. With the current cameras that have very basic AI capabilities, the cameras can perform many functions such as location and tracking, the capability to identify people and other objects, track direction and motion to predicting location. Similarly, the cameras also have the capability to draw automatic boundaries with image segmentation. Tying the camera capabilities with access control applications would enable a completely new set of use cases, such as the ability to interact verbally with security systems, thus increasing the intelligence of the cameras as well. With access control applications tied to the cameras, one can grant access to the various office spaces or the property, and at the same time continue to preserve the privacy of the data by performing all the inferencing locally on the device itself. And the last one is increasing intelligence at the edge, which pose estimations or even interacting verbally with the security system. Now, you have seen the variety of AI and ML-based use cases that are possible by shifting the compute to the edge. In order to effectively achieve this, it is super important to ensure that there are common methodologies present in order for machine learning to seamlessly work across a variety of devices. And this is very critical because of the heterogeneous nature of the devices. This is the reason why we at ARM have been diligently working in order for any developer anywhere targeting ARM hardware to be able to take any network trained in either the TensorFlow ML framework or PyTorch or any other ML framework and compile it down to a binary that will run on the full range of ARM products. Based on the needs of the network, the appropriate hardware, which in this case could be the Cortex-A devices or Cortex-M CPUs, the Mali GPUs, or even NPUs or TPUs can be targeted. This way, the developers don't have to worry about the underlying hardware. At the same time, the framework also provides capabilities for the super performant kernels that have been handcrafted into the ARM compute library and CMSIS-NN to run in an optimized way, and if not, then have the appropriate fallback mechanisms. For example, an NPU can fall back to either a GPU or to a CPU. The second trend that we talked about is security. We see varying levels of security being deployed across cameras around the world. But I think moving forward, it is super, super important to ensure that all the cameras adhere to key security aspects. The first one being the root of trust, where we have implicitly trusted functions that the rest of the system or device can use to ensure security. The second one is data security. This is also key because no one wants to have their data hacked. So it is essential to ensure that all the data flowing through is encrypted and kept secure. And then end-to-end security. We looked at the architectures under deployment, and it is very clear that the data all the way from the image sensor to either a local gateway or cloud storage or even local storage, and even the data that can be used to train the models needs to be encrypted and maintain security. The fourth one is data privacy. These cameras are recording all the data, and some of which could be personal data. And it is super important to ensure that all of this personal data is anonymized before using it for different purposes. The fifth vector is secure boot. This also ties to the root of trust, where in this world, you might continuously receive firmware updates to either fix older bugs or security vulnerabilities. And you need to ensure that the firmware is updated securely and the SoC can boot securely without any malware. Last but not the least, it is the secure key management, which is also super essential because all the security elements are only possible if all of the key management is secure. In order to achieve these requirements, we at ARM have proposed a standard, also called as PARSEC, in order to have a platform level abstraction for security so that the software layers above talk to the common PARSEC layer without worrying about the myriad of security combinations or implementations at the lower layers, which can be either a local HSM, remote HSM, discrete TPM, or integrated TPM. PARSEC just provides a common layer for all the application developers. At the same time, we've also been working on something we call it platform security architecture and a certification process, in short form called as PSA. PSA can be thought of as providing the recipe, which includes architecture documents and ingredients such as open source code, threat models, dev boards, and models to make security implementation easier, no matter your level of security expertise. So through this approach, we are working with different partners in the entire value chain in order to embrace security for all future designs. The third trend, as we described, is cloud native. By designing future camera products with cloud native capabilities in mind, one will be able to scale camera and vision products to unprecedented levels. If you look at the view here on the right, wherein if all the applications are deployed using a service-oriented architecture with containers, a device can be continuously updated, and this is what we talked about. One of the key advantages of this architecture would be to enable new use cases or use case scenarios that one might not have envisioned in the past during the shipment of the product with a simple on-demand service deployment post-sale, either through an app store or just an update of software or a container. A simple example can be to deploy a new and updated license plate recognition app a year after the purchase of the cameras. At the same time, one of the other advantages with this architecture would be to enable continuous online machine learning updates based on the data pertinent to the camera installations. That is, to be able to use the data that is captured and use it to train the models. Of course, you need to make sure the data is protected, labeled correctly, etc. But you can imagine the potential of this sort of a cloud native architecture. With this, the model would be relevant to the specific use case, thus increasing the value and the lifetime of the camera itself. The third use case that would benefit from this architecture would be to enable concurrent execution of inferences. All of this is possible due to enabling a service-oriented architecture using containers and thinking cloud native first. Now we walk through various trends that are changing the camera landscape with security, machine learning, cloud native applications and application development, and which are key for software-defined cameras. The other important aspect that will really bring together the security camera and vision products is the adherence to common standards such as Project Cassini, ARM is working with many ecosystem partners, OEMs, ODMs, silicon vendors to drive a standards approach in order to scale deployments by replacing custom solutions with standards-based solutions and becoming the platform of choice for future camera deployments. Now, if you look at many of the current solutions, it is clear that each silicon provider would provide their own vertical stack of firmware, operating system, and SDK, and specific applications. You can imagine how tedious this would be for a new and upcoming developer to write a new software application. Instead of this path, we at ARM are embracing common specifications so that many silicon providers and partners such as OEMs and ODMs can provide the silicon and firmware that adheres to these standards, in which you start off with a common distro, just download it from the web and expecting it to run on your silicon. Then once this is achieved, application developers can easily deploy their apps on top of these common operating system without worrying about underlying hardware. This is an initiative which is driven by ARM called System Ready or Project Cassini. And so far, you will see that we have already been working with quite a few number of companies for the last few years. And here you can see a broad list of companies that are already on board, and we expect many more to join in the year 2021 and in the upcoming years. And 2021 promises to be a very important year in the evolution of this program, as we are seeing new platforms from new silicon vendors being Project Cassini compliant across various use cases, and they're getting certified and supported. It is also the year where we will be pushing from our side for standard certification for the program to scale with many more partners, especially related to cameras and IoT devices. So now, with these standards and key trends across the vectors of security, machine learning, and cloud native software development, it is very clear that different functions can be enabled by software and can be abstracted from hardware. Now, using the cloud native service-oriented architecture model, functions are delivered as self-contained units of software, along with a centralized management of these services. This is what you see different functions as function A, function B, and function C. This architecture would assist with ease of integration into the cloud service provider's infrastructure. And on top, provide seamless software and machine learning development on the cloud and deployment at the edge. Vendors can utilize a system to collate available services and push them out to cameras in the field and manage them centrally. As a result, these cameras can be considered to be software defined, and their functionality is defined by the software they run, which can change over time. Just imagine if you already have a set of cameras at an office, and you buy a new camera to install it in a separate location. All you have to do is download a config file, and then boom, your camera is up and running within a few minutes of buying that. This is exactly what we mean by software defined, because it really changes the landscape and makes a lot of things much easier. So you've seen the key trends and how cameras can become really advanced. So we at ARM would like to provide a reference solution that emphasizes on these key trends so that we can enable the ecosystem to thrive. So this is the reason we've been working on enabling a software architecture as well as part of this reference solution. You can see that this software stack is also based on the key standards that we just talked about, such as Parsec, PSA, and System Ready. So let's start from the bottom of the stack here. So the platforms are at the bottom of the stack, where all these platforms are created based on ARM System Ready specifications with respect to UEFI, U-Boot, trusted firmware, etc. The main advantage of doing this is to be able to pick a standard Linux distro, as we mentioned, and download it from the web and be able to run seamlessly on a system-ready platform without worrying about any custom compilation. Then the layer above, we want to provide the orchestration layer to be able to run containerized applications. So here we would like to provide K3s as the orchestration layer. Then the layer above is the machine learning and computer vision libraries. ARM has been providing support for machine learning through ARMNN and ARM Compute Library, and would slowly like to move towards TVM in the future so that customers can develop their ML applications using standard ML frameworks such as PyTorch or TensorFlow. And we at ARM would provide tools easily to translate to TVM, and this thus would automatically use the right hardware available without the application developer needing to worry about whether this would run as fast as they could. Similarly, on the computer vision side, we are aware that there could be internal or third-party ISPs that would be used in these systems. And we would like to support open standards such as Video for Linux, OpenCV, and all the BLAS libraries so that developers can take advantage of these common layers on above the stack. Now, moving up the stack is security. This is where we plan to provide the example reference designs with Parsec, which is the open source platform abstraction layer for security that we talked about, and along with also provide a PSA or platform security architecture certification process so that you know that the product will be secure when deployed in the field. The layer above would be then the communication layer to either communicate directly to existing NVR systems or many cloud services such as AWS, Kinesis, etc., and or be able to connect to your favorite cloud service provider. Then, of course, we would provide containerized applications for inferencing, analytics, and storage. And on the topmost layer, we would finally provide the connectivity to the cloud with the capability to run camera and vision software applications by taking care of also the edge services. So, in order to cater to these trends for the future cameras, we at ARM also provide the key hardware elements needed for a camera SoC. Starting from our well-known Cortex-A CPUs, Cortex-M low-power CPUs for some always-on kind of implementations, then the Mali image signal processor IP and the GPU, along with our Ethos line of machine learning IP. So these key elements, along with the reference software, can really push the envelope of these key trends that we have been talking about. So the ARM scalable ML computing solutions will enable you to think. The Cortex-A and Cortex-M devices will be able to make you sense. And then the advanced Mali image signal processors will be able to see. So to summarize, the transformation of computer vision and camera products are being underpinned by three key trends: shift to edge compute, the focus on security, and cloud native enabling machine learning capabilities. And as we mentioned, ARM is working with many ecosystem partners such as OEMs, ODMs, and silicon companies to drive a standards approach in order to scale deployments by replacing custom solutions with standards-based solutions. And with that, thank you for listening and have a great day.
Hey there, Parag. What a great presentation.
Thanks, Jordan.
No problem at all. Thanks for joining us on the stage. Okay, so to the audience, I know it's late in the day, and for most of you, and this will be your 8th presentation of the day, but I'm sure we can ask Parag a few questions. So we'll just give it a few moments. We've got about 5 minutes or so. So all questions welcome. Don't be shy. Post them in the chat there. Parag's given up some of his time to be with us today, so let's dig a little bit deep. I know it's been a lot of content to digest, but I'm sure someone wants to ask one question. Or any further thoughts from yourself, Parag, just to elaborate on your presentation?
No, I think all I can say is to summarize, right? I think it's a good chance for a big transformation to happen, and we are more than happy to work with anyone who is interested to push forward this transformation and expedite. So yeah, if anyone wants to reach out, yeah, feel free to reach out, and more than happy to discuss further.
Cool. It is usually the case at this time in the day, Parag. People usually, they watch it on demand and then they'll get back to you. But we've got a couple of questions coming in now. So thanks, Jacob. So cool architecture. Were there interesting use cases that you stumbled upon?
Yeah, I think from a use cases point of view, I can give you a variety of use cases. And a simple example is, imagine to be able to recognize a license plate of a car which just traveling at, say, 60 miles per hour, right? Like right now, yes, you can recognize license plates. They're even used to open gates at at parking lots, etc. But to be able to do this live on a fast-moving car is, I think, a use case that we would like to definitely eventually be able to cater to. Again, if you expand more, imagine capability to detect, say, 50 or 100 people in a scene, clearly segment the people and try to get more information about the people there. Again, keeping all the security aspects in mind, right? So I think there is just an enormous amount of compute that will come to the cameras themselves, and the number of use cases will just, I mean, these are just two that I could think of on top of my head. If you just take the combinations of these, you can come up with 1,000 relatively easily.
Cool. Yeah, agreed. And then any sort of privacy issues that you like envision happening in the future, or that you've already encountered?
No, I think privacy is definitely a key thing that we keep in mind. Actually, a couple of things that we are trying to do is there's a lot of data that gets passed through from the camera to, let's say, you're trying to use the same data to train the models, etc. The data needs to be encrypted, made sure that all like the information that is private needs to be removed before sending it to the models, etc. So we are working with few companies in order to make it a little more efficient. If we can do it through software, for example, instead of hardware. So there are a couple of companies that we are partnering with to make this happen.
Okay, nice, understood. So thanks for that question. And next up, so would using the concept of flow be useful in enhancing the quality of detection of some anonymity while footage, oh, sorry, I've lost that question. While footage is being captured?
So yeah, I think the question is flow as a framework. Is that the specific question, maybe?
So would using the concept of flow be useful in enhancing the quality of detection of some anomaly while some footage is being captured?
I don't know the concept of flow. What does it mean? Maybe
optical flow.
Optical flow. No, I don't know that. Sorry.
Ryan, maybe if you want to just elaborate a little bit more. So Gareth Stokes, thank you. Really enjoyed that. We've seen a lot of combinations of commodity cameras with AI in the medical EG devices, diagnostic space. Not really a question there, but thanks for pitching in, Gareth. So if we look at this from, I don't know if this is a follow-up question, Ryan. If we look at this from an anomaly detection standpoint, how far, in your opinion, would spiking new neural networks go in terms of performance in these scenarios?
Spiking neural networks could go in scenarios. No, sorry, I don't know the answer. It's an interesting question, though. Yeah, I think you're trying to see how can you use the neural or spikes in the neural networks to anonymize the data, if I understand the question. Yeah, that's something, I don't have an answer, but it's an interesting thought, yeah.
Okay, cool. So that's pretty much it for the questions then, Parag.
Thank you.
So what's that from, Orion? Yeah. Okay, cool. But yeah, massive thank you for taking the time to put that presentation together. One more question from Jacob. So what's your opinion on the restrictive European data protection legislation? Is that maybe something helping you to sell your highly secure solution, or is it rather hindering?
No, I think it does help because we take those requirements from the European Union and make sure that the solution that we are providing caters to that requirement. So this is one of the key things that we are doing. It absolutely helps us to pitch in and actually serve the requirement. So yeah, absolutely, it's helping.
Perfect. And on that note, we'll wrap up. So I'll post a link to the next presentation in the chat. But yeah, big thank you to our partners, ARM. Big thank you to yourself, Parag. It's been a pleasure hosting you. And yeah, thanks everyone for sticking around. One more session to go.
Thank you. Bye.
Thank you, Parag. Take care. Bye-bye.